Good morning. Today I want to talk to you a little bit about programming languages and IDEs. Now, these are a few of the languages in the world today. There are in reality hundreds of thousands of these. And I don't know all of them. In fact, I don't know anyone who does. But hey, c'est la vie. So, in the world today, there are a lot of different programming languages. Thousands, if not millions, of them have been created. But what are the big differences between them all? Well, today we're going to look at one of them, which is the difference between interpreted and compiled languages. There are two types of languages, compiled and translated. Python, which we're learning now, is a good example of a translated language. Now, a language like Python works by using a translator. So, take the Python code, and every program that runs Python has a translator program on it. And the code you write goes through a translator and is then able to work on a Mac, or it's able to work on Linux, or on Windows. So, you write the code once, and it runs everywhere, which is handy if you want to make your code quickly to work anywhere. Say, for example, in class, most of the Python work we do, I write at home on my Mac and then bring it to class and run it on a Windows PC. So, write once, run anywhere. That's how translated programs work. The alternative, though, is compiled languages. So, say you write your program in a compiled language, like C++. C++ has a compiler, and the compiled program will go into the compiler and will come out designed to work on one computer. So, a compiled program is compiled to work on a Windows computer. On a Mac rather. Would it work on these ones? No. So please forgive my handwriting, but this is how it works. Compilers make code specifically for one type of computer. Now, this makes them faster because A, compilers take all the code in at once, whereas translators do it line by line. And B, because if you are making something specifically for a chipset and an operating system, then it is going naturally to be faster. So say you want equipment to be streamlined and made just for you. So compilers will make faster code. Why? Because they only work on one chipset, on one operating system, so are more efficient. And this is why games makers and the like will use them. Anything demanding speed will use a compiler, whereas anything that wants to work anywhere will use an interpreter. So guys, C++ and compiled languages generally are always faster. Any application or language that needs high-speed design or power and performance will use a compiler and rewrite the program for every single operating system out there. Anything that wants to work on anything will use an interpreter. Python code can run through translators on all these systems, on Apple, on Linux, on Windows, iOS sometimes, definitely work on Android, even Ubuntu, which is the sixth bottom right symbol there. It will run on all those quite happily. So, programming languages. The two types of languages we need to know about are compiled languages and interpreted languages. Compiled, run on one system. Translated, run on all systems. So, now, when we come to write our code, the code all looks the same, but there are several features in these programs, which you used to write them in, which help us. So, I'm going to do a quick review of IDEs. Now, IDE stands for Integrated Development Environment, and this means all the features you need to help you be a coder are in one small, sweet software package. So, what are a few benefits or features that IDEs have to let us code more easily? Well, let's find out. So, for a start, IDEs contain a compiler which lets us make the code we've written into a functioning program. So there's a compiler or an interpreter sitting there. They also have text editors. As you can see there, it's typing the code in, so you can actually write the code and run it or build it from the same program, which is, in my experience, pretty handy things to have in a programming language. You also, though, have a few other things which you can work with as well. So, here, this bit of Python code, IDEs often have built-in libraries of code, like these two up here you can import and use. So you don't have to go and rewrite lots of mathematical symbols, lots of ideas, lots of code. You can use ones that other people have written or that come with it to speed things up. They also contain spell checking or error checking as you type to tell you where problems could be or what things they're not sure if you can spell okay. And finally, they also contain things like autocomplete, which would help you write the code. So you type in .grid and it will say, was it true or false? So, autocomplete is a big bonus of an IDE. So, to summarise, today we have learnt about compiled languages, which are faster because A, they process code all at once, and B, they're made for a specific chipset, and interpreted, which are handy because they run everywhere, but they are slower because they are translated line by line in the interpreter. We have learnt about IDEs and common features like compilers, text editors, autocomplete, and error correction. I hope that was useful, and I hope you enjoy the accompanying Quizlet. Good night, and good luck.